Welcome to LiveTutelage.com, best e-learning portal for IIT JEE, NEET and Foundation.
Hello students, in this video I will discuss about Raoult's law for volatile mixtures. Volatile substance is a substance which has a greater tendency to evaporate. Assume that this is a solution is given and this solution is composed of two volatile components A and B. And when it comes to the vapor pressure of these individual components in the solution, Raoult's law states that the partial pressure of a component, individual component in a solution, this is a solution, is equal to its mole fraction multiplied by the vapor pressure of that component in pure state. If we assume that partial pressure of component is P and mole fraction is X, and the vapor pressure of that component in pure state when it is not mixed, means it is not in the solution, in individual state, is P naught, then the relation can be given by Raoult's law. P is equal to P naught into X, where P is the vapor pressure of component in the solution and P naught is the vapor pressure of pure solvent when it is not mixed, and X is the mole fraction. If we have to find the vapor pressure of individual component in the solution, we can apply Raoult's law. Here we have PA, that is the vapor pressure of component A in the solution, is equal to P naught A. It is the vapor pressure of component A in pure state, and into XA, that is the mole fraction of component A. In a similar manner, we can find the vapor pressure of component B in the solution. Here we have PB is equal to P naught B into XB. And if we have to find the vapor pressure of the solution, we can add the vapor pressure of each individual components. It will give us the vapor pressure of the solution. Here you can see that you can say add up these vapor pressures of both components. Here we get P represents the vapor pressure of solution is equal to PA plus PB, and we can add up these expressions. This gives us the vapor pressure of solution having two components, volatile components in the solution. Now here you can see that this expression is having mole fraction, and there is one interesting fact about mole fraction. Whatever the number of components are available or present in a solution, the total mole fraction of those components is always equal to 1. There are two components in this solution, therefore the total mole fraction of these components will be equal to 1. So that's why this relation we get XA plus XB is equal to 1. In case if the mole fraction of one component is known and say the mole fraction of another component is an unknown, then by using this relation you can find out the mole fraction of another's component. It can also be written as XA is equal to 1 minus XB. If the mole fraction of XB component B is known, you can plug in the value, then you can calculate the mole fraction of component A. We can use this expression, and so we can use this expression to plug in the above formula to simplify it. Here we have P is equal to P naught A, and in place of XA we can use this expression 1 minus XB plus P naught B into XB, and is equal to, this is the simplified form of this Raoult's law for the vapor pressure of a solution we get. Now this is a problem given here, and in this problem I will show you how you can calculate the vapor pressure of a pure component in a solution. The problem says that vapor pressure of pure component A is 70 mm of Hg at 25 degrees C. It is pure component, means it is not in the solution, it is not in mixtures. So therefore we get P naught A information. This is the data we get from this information. It forms an ideal solution with another component in which the mole fraction of component A is 0.8. From this we get XA, mole fraction value is of component A. If the vapor pressure condition is there, if the vapor pressure of the solution is 84 mm of Hg, means here we get P value, that is the vapor pressure of solution at 25 degrees C. Question asks that the vapor pressure of the pure component B, means we have to find out P naught B value. This is what we have to calculate. If you look at the first and second sentence, you can see that P naught A value is given and XA value is given. From this information, we can find the vapor pressure of component A in the solution. We apply Raoult's law. Here we have PA is equal to P naught A into XA. PA represents the vapor pressure of component A in the solution. We can plug in the value. P naught A value is given 70 mmHg, 70 mmHg multiplied by XA, mole fraction. Mole fraction does not have any unit, equal to, we can do the calculation. Here we have 70 and 70 is multiplied by 0.8 and the value which we get, that is 56 mmHg. Now you can see that the solution is having two components, component A and component B, and the mole fraction of one component is given. Then by using this relation, we can find out the mole fraction of another component. Here we have XA plus XB is equal to, total mole fraction of both components is equal to 1 in a solution, and XA value is given, that is 0.8 plus XB is equal to 1. We can transfer this value on right side. Here we have XB is equal to 1 minus 0.8. Here we get 0.2. Now we can apply the formula for the vapor pressure of a solution. The formula is, that is Raoult's law. Here we have P is equal to P naught A into XA plus P naught B into XB. XB value is known, XA value is also given in the problem. P naught A value we have already calculated, that is 56 mmHg, and P is the vapor pressure of solution. Vapor pressure of solution. We can plug in the value and we can calculate the vapor pressure of component B in its pure state, P naught B. Now let's plug in the value. Here we have vapor pressure of the solution is 84 mm of Hg. Here we have 84 is equal to P naught A, it is 56 into XA, that is the mole fraction of component A, 0.8. Here we have 0.8, I just put X, plus P naught B into multiplied by XB, that value we have got 0.2. Now we can do the calculation. Here we have 84, we can multiply these values. Here we have 56 is multiplied by 0.8. The value which we get, that is 44.8 plus P naught B and multiplied by 0.2. We can subtract minus 44.8 on both sides. It will cancel out. We can do the subtraction. 84 minus 44.8, it gives a 39.2. Here we have 39.2 is equal to 0.2 and P naught B. We can transfer 0.2 on left side, or we can divide this setup by 0.2 on both sides. We get the setup P naught B is equal to 39.2 and it is divided by 0.2. Here we have, it is divided by 0.2, and the value which we get, that is 196, and the unit is mmHg, because vapor pressure is given in mmHg. This is the vapor pressure of component B in its pure state. You can see that how I calculated the vapor pressure of a component in its pure state by using Raoult's law. This is the formula I used. Thank you.
If you like this video, please click the like button. If you have any questions or suggestions, please comment below. For more updates on IIT JEE or NEET exams, please subscribe to our channel to get a lot of updates. Support us by following us on Facebook and Twitter. To sharpen your skills, please try out our test series on LiveTutelage.com. Thank you so much for watching. Have a great day.